Hi guys, we're gonna discuss Graham's law of diffusion and effusion of gases today. Let's discuss the terms diffusion and effusion of gases first. By diffusion we mean the spontaneous mixing of different non-reacting gases. That means that if you leave two gases that do not react with each other in a room, they would collide and mix randomly with each other to form a homogeneous mixture. The gases move from higher to lower concentration. For example, during bursting of a balloon, the gas escapes suddenly and mixes up with the surrounding air. Another example is perfume. You spray it in one corner, it mixes up with the air of the room and can be smelled in the other corner of the room as well. Effusion of gases is very different. It means controlled mixing or passage of gas molecules through a small orifice or hole. Gas molecules spread one by one without collision to form a homogeneous mixture. Molecule escapes through tiny holes, for example, like a leakage in a balloon or puncturing of tires. Coming to Graham's law of diffusion and effusion. In 1828, Thomas Graham proposed the law which states that the rate of diffusion and effusion of two gases is inversely proportional to the square root of their densities or molecular masses at same temperature and pressure. It also gives us the formula R1 over R2 equals square root of D2 over D1. Understanding this equation, take D1 as density of gas A and R1 as the rate of diffusion or effusion of gas A. Similarly, D2 is the density of gas B and R2 as the rate of diffusion or effusion of gas 2 or gas B. Now taking the equation as stated in the law, R1 is inversely proportional to the square root of its density. Removing the sign of proportion, we add the proportional constant. Similarly, for gas B, we add the proportional constant and we get two equations. Dividing equation 1 and 2, we get this equation where the proportionality constant, it gets cancelled out and we get this formula R1 by R2 equals square root of D2 over D1, which is the formula of Graham's law of diffusion. The density of the gases could be replaced with their molecular masses. Thank you and subscribe to my channel.